Hello everyone, Aaron here, and welcome back to Leetcode. Today we are solving the sort array by parity problem. Given an integer array nums, move all the even integers at the beginning of the array, followed by all the odd integers. I'm not sure that makes grammatical sense. Anyway, sounds like evens at the front, odds at the back. Return any array that satisfies this condition. So we don't need to specifically get 2, 4, 3, 1. We could do 4, 2, 3, 1. All we need to do is make sure we've got evens at the front and odds at the back. So immediately, my mind is saying this is very much like in quicksort when you have to put all the things larger than the pivot on the far side and smaller than the pivot on the near side. Except here our pivot isn't a specific value. We're not doing larger, smaller, we're doing odd, even. But I think there's this idea of the algorithm which has two pointers, one sweeping from the back and one sweeping from the front. And I think we're going to try and borrow that idea. Note that the returned array must be malloc, assume caller calls free. Oh, is that saying that we can't edit in place? That's rather strange. Why do we need to specify the return size? We know exactly how big it's going to be. It's going to be exactly the same size. Okay, that's slightly strange. But anyway, malloc size of int times num size for int I equals 0, I is less than num size I plus output I equals nums I. So all this is doing is just copying the array across. And we want the value in return size to be equal to num size. That must always be true. I have no idea why we're required to set that. Anyway, so now what I want to do is have int I equals 0, int j equal num size minus 1. And then what I want to do is, while I is less than j, what I want to do is while output I mod 2 is equal to 0, so while it's even, I gets incremented, while output j mod 2 is equal to 1, while it's odd, j gets decremented, and then if I is less than j, the idea here is we've swept I along. This is on the low side. So while it's even, we've kept on going. And it will basically keep going while it's less than j. And j is greater than I. So I has swept up until it's either equal to j, or we've found something that is odd. Similarly, j is sweeping down until either it's pointing at something that is even, or it's less than I, or it's equal to I, less than or equal to I. And then what we want to do is, well, if they've met, then we don't want to do anything. Otherwise, if I is still less than j, what we want to do is have temp is equal to output I. Output I is equal to output j. Output j is equal to temp. So obviously we could do this all in place, but we've had to copy them across for some reason. I get it. It's nice that we're treating the array as immutable, but this is C. Everything is mutable. Return the output, please. So once we've got to here, if I is not less than j, then we're completely done. Otherwise, we want to keep on going. I wants to keep sweeping up, j wants to keep sweeping down, so on and so forth. Yeah, I now must be pointing at something even, and j must now be pointing at something odd, so it is going to keep on trucking. So let's have a go with this input here, 3, 1, 2, 4. So we've got the 3. We find that that's even. Odd. It is not even. So we're going to have I point here, and j is going to be pointing at the 4. Same problem. That is even and is not odd. So then we're going to swap them. So we're going to get the 4 down here, and we're going to get the 3 up here. And then we're going to go back around again. I is going to step up, j is going to step down, and again they're going to find, whoops, these things are wrong. This is a 1, which is odd, and this is a 2, which is even. So they need to swap over again. Then this is going to step up, and then what's going to happen is, well, j isn't going to step at all because j would be equal to I. We wouldn't do the swap because I is not strictly less than j, and we're going to jump out of our while loop. So we should end up with 4, 2, 1, 3. 4, 2, 1, 3. It's a valid solution. Let's give it a test. See what syntax errors I've made. None apparently. Let's use all the example test cases. Perfect. All right, fingers crossed. Let's submit it and see what happens. Hey, we're done. We were pretty fast, faster than 70%, but we used a lot more memory. And I suspect that's because of the copying. In fact, if we get rid of the copying, if I just did that, how badly does it die? How did we get so slow? We did a lot less work. And we got slower. I'm going to submit that again and see what happens. Okay, that's just strange. It's very inconsistent in its runtimes. We're playing around obviously in the absolute limit of of the measuring ability of Leetcode. So I'm not going to read too much into these. These all seem to be basically randomly generated numbers here. Remember, these two were exactly the same submission, and this one was actually technically doing more. It was doing more allocations, and it was doing more more copying. In fact, it's hard to imagine a solution that does less work than this, because it's literally moving exactly what needs to be moved and no more. I don't know. Anyway, I think that'll do it. Fairly short one today. Thank you very much for watching, and I will see you all tomorrow. Bye. Strange.